carbon disulfide liquid reacts with oxygen. Those are reactants. Oh my, it's too early. Oxygen is a diatomic element. Okay, so those are our reactants, and they're going to be used to produce carbon dioxide and sulfur dioxide gases. All right, before we can do stoichiometry, we need to balance the equation. So let's balance it. All right, we've got 2 sulfurs on the reactant, only 1 on the product. We need to put a coefficient of 2 here to balance out the sulfurs. So that's going to give us 6 oxygens on the right side, and looks like we just need to put a 3. Put a 3 there, and it looks like we are good. All right. All right, so now we can do stoichiometry. Step one is to convert to moles. Oh, hold on, let me read this. Calculate the volume of in milliliters. All right, so they want you to calculate some quantity of this sulfur dioxide, and they're giving you quantity of oxygen. So this is what they want us to do, and they're giving you 27.9 milliliters. Now this is yikes. All right, so you could take milliliters, turn that into liters, turn that into moles, turn that into moles of sulfur dioxide, turn that into liters, turn that into milliliters. Yikes, that's a lot of conversion factors. Well, let me show you a shortcut. Shortcut. We love shortcuts. You can do all of that, and you'll see, because gases at STP, which is what we assume, right? They all have the same relationship, which is 1 mole is equal to 22.4 liters. All right, and then 1,000 milliliters is equal to 1 liter, and so it's going to all end up canceling out. It's going to all end up canceling out. Right? So, just reading this one more time. So here's the shortcut. We're going to start with the value given, 27.9 milliliters of oxygen, and we're just going to use the volume. These mole ratios can be used as volume ratios because they're gases, right? They're both gases at STP. All right, we're going to assume that in this chapter. All right, so what we can say is, we want to get rid of milliliters of O2, and we want to just end up with milliliters of SO2. Let me just read this one more time. Calculate the volume of SO2. Good. And we can just use these coefficients like that. Boom. What a shortcut. All right, and we can only do this because these are gases. All right, so not a question you're likely to see on your test. All right, but it's good to see something like this. Let's punch these numbers in. $27.9 times 2 divided by 3. 18.6 milliliters of SO2. All right, that was a nice shortcut there.